Okay, so welcome everybody once again. We are starting now. I would hope those that have not joined, they were not very fully aware of the timing, and then they will catch up. So, Frederick, your microphone is muted and it's a bit.
Okay, can you hear me?
Yes, I can hear you.
Okay.
All right, that's great. I mean, there was a sound coming in from your background, so I was wondering if you could.
Okay. Mute it.
Yes. Thank you. All right. So we've started, and just a little consensus, right? From the form submitted, we got about 35.5% beginner. So I don't really know who is a beginner here or who is not. So I would at the time being just try taking from the basics and getting the recording out. You will get the recording as time flows on. Hope everybody can hear me clearly. Sound check, sound check. Can you hear me?
Yes.
All right. All right, that's great. So I would, start from where we have big O notation. I would like to ask, is there anybody that knows what big O notation is and how it applies to data structure and algorithm? Is there anyone? Big O notation. Dogs, big O notation. Oh, difficult to write here. Anybody? Oh, newbie. All right. Okay, so I would assume that everybody here has tried programming once or twice. You are familiar with at least a programming language. If you are not, some of the concepts we are sharing might be a little bit technical. I will be using Java for the classes. I would love to use JavaScript, but I mean, it's almost the same concept everywhere you go. You can use it in Java, with some exception of some languages like maybe Kotlin or Python. But I mean, if you get it with data structure and algorithm, you can really flow with everything that's going on. So without further ado, I would say big O notation, right? It's how you measure the scalability of your code. So there's something called pillars of programming, or what makes good code. The two things that make good code. Sorry, try to share my screen. A window. All right. Let me just go for the notes for today. Two things that make good code. We have readability. We all know what that is. Your code should be able to be readable. It's a code where, I mean, if you are going to have somebody else inherit your code and they don't understand what it's there, it's crazy. But mostly what we are focusing on data structure and algorithm is not on readable code, but majorly on scalable code. And when you're talking about scalable code, you have something called time complexity and memory complexity. Now, the time complexity is the time it takes for your code to run, right? So there are some algorithm you write, it will run faster. There are some it will run slower depending on the input of the data. And the memory complexity is how you choose to store your variables. There's this sheet, big old cheat sheets. Of course, I will share with everybody, right? I will share with everybody on the group after this call. So you want to take a look at that. And I mean, it's the foundation of everything we do with data structure and algorithm. So I think I mean, I've not introduced myself, so I'm Peter Enenche. Most of you, or some of you know me, I'm Peter Enenche. I'm a developer, senior Android developer with Turin. And so a few people from Abuja Developer Circuit, they knew when we were doing our journey there in Abuja, we were looking for gigs. Or thoughts. I mean, I was looking for gigs as low as 20K that time. So I mean, if you're a newbie here, so don't feel as though this guy has over 50 years of experience. Nah. I was just knowing some of these concepts that helped me, and I wanted to share it out. So over to our BIGO notation, we have things called time complexity and memory complexity. And I said time complexity is how fast your code runs, and memory complexity is how much space your code takes while running. So coming to this cheat sheet, just some things I want to show. What causes time complexity in a function? You have operations, addition, subtraction, multiplication, comparisons, looping. And I mean, it's this looping parts that we have majority of the culprits in what they do, right? Because this is where it will determine how fast your code will run. I mean, operations and comparison, you can they run in like maybe what we call O of n, but we'll get to that later. Operation and comparison, they run in little time. Like if you're adding 1 plus 2, you are getting 3, and it doesn't have to look through 1,000 records to get 3. If you're adding 1 million to 1, it's 1,000,001. It doesn't take much time compared to if you are looping through 5 records. If you are looping through 5 records, you are going to take more time than if you are adding 2 numbers. If you are looping through 2 records, you are even going to take more time than if you're adding 2 numbers. It's like looping this side. And then functions too. You can have a code that call multiple functions. I don't know if you're familiar with clean architecture or some of the solid principles. It's best to have functions that run, breaking code into modules than having one super function that you call the function maybe transport man to moon function. That's take man from Earth and take them to moon. No, you have to break it down, start rockets, initiate this and that. So you have to have multiple functions, and those function calls will take both space and time complexity, right? So just some introductions on BIGO now. So like I said, BIGO is, when I say BIGO, is the notation you take to know how well your code is performing in terms of time and in terms of space. But we focus on time for now, and I will explain space later. So you have something called O of 1. That's when you have constants. There's no loop at all. Like if you're having an operation, that's an O of 1 operation. It's operating in linear time. You are not doing anything. For instance, I mean, how many of us can see the docs? This. I mean, if you can see it, you can just raise your hand on the group. This doc we have here. Can you see it? All right, great. So if you have, say, 2 plus 3, this is going to be equals to 5. I mean, your compiler doesn't need to have too much time to compute this. Same thing if you have an array that has only 1 element, right? There's only 1 element inside the array. To call anything inside this array, you are going to operate in linear time, because if you call an array, say, let's say this array is an eraser here. Eraser. Oh my God. Anyways, say this array
is no longer showing.
Pardon?
Your screen is almost showing. Your screen
Oh, my
sharing
screen is
showing.
not showing. But can you see the Jamboard Google Docs?
No.
Okay. Is sharing a window, hide. Okay, let me share my whole screen. Thank you so much for that. Let me stop presenting, share your entire screen. So what about now? You should see it. Okay. Yeah, I think you should be able to see it now.
Is it blank? Okay, yeah, we're seeing now.
Yeah, okay, so you've seen this document. All right, sorry. I really made a mess trying to erase everything here. So just ignore this erasing. So I was talking about this array where you have an array of just one element. So access the content of this array, you are doing it in linear time because the array only has one element. So you are going to get element at 0th index. So that is linear time. I mean, it doesn't get better than linear time. You can't do it in no time at all. So that's where we talk about linear time. But then once the array gets 2 elements, we'll get there. But let's talk about not here. O of log n. Usually searching algorithms have log n if they are sorted. So if you are searching for a number in an array, say we have an array of elements and we have, let me use this Google Keeps. Let me use Google Keeps. It's easier to take. So say we have an array of elements. Is it visible enough what I'm typing on the screen? So let's say this is an array of these elements. Array is equals to this.
It's really small.
Okay, so tiny.
Yes.
So tiny, so tiny, so tiny. So let's say we have an array of elements 10, 12, 89, 90. Now this array is sorted already. So the time it will take to find any array, I mean, the time it will take to find any elements in this array, it's not going to be linear time because you are going to pass through 1, 2, first element, second element, third element, fourth element, because the array is higher than 1, you know. So it's not going to be linear time. But the fact that the array is sorted, you are going to get what you know as log n. Yeah, log n, because at this point n, log n. At this point, if you find maybe 89 at this point, you can quit. You don't need to go through all the elements. But in an example where you have an array that's something like this, so maybe we have 2 here, then we have 109 here. This array is not sorted, you know. So you are obviously thinking of looping through all this, but we'll go into more details on this later. But just know that on that big O notation, we have log n. Log n is logarithm search. When you're searching for something binary, yes, there's an algorithm for binary search, but we are going to do it much later in the course, right? But know that there is this. For what we are going to do now, we are really not going to use. We are not going to get to log n. We are doing O of 1, O of n square, and O of n, maybe 2n, no? But O of 1, O of n square. Then O of n log n is doing sorting operations. We are going to touch sorting operations later. Then O of n is what you call linear for loops, right? This one is constant time, so it's 1. So this is linear because if you are looping through these elements in this array or any array that you have to go through all of them once. And n in this case here, n in this case signify the size of the array. So if the array is 12, you are going to loop through it 12 times. If the array is 20, you are going to loop through it 20 times. If 100, you are going to loop through it 100 times, and so on and so forth. But we are going to touch through more of this and we understand it later. But for now, you have to know that big O, if you are doing operations like 2 plus 3, 2 times 3, if A is greater than B, I mean, the compiler does this in, you know, constant time, just as fast as it can. But if you are saying you want to find where 12 is located in this array, you have to go through it all. Of course, you are going to say it's not going to look through all the elements since the size is 1, 2, 3, 4, 5, 6. It's not going to go through it 6 times because 2 it's not at the 6th element. But then it moves us to the next thing where we talk about the rule book of big O notation. How do we evaluate big O notation? Because once you are in interviews, especially with Google, they are going to ask you what is your time and space complexity. So the rule number one is always take the worst case scenario. What does that mean? Say for instance, we have this array and they ask you to find, let's put 1 here, and they ask you to find where 1 is located in this array. Since 1 is at the first element, you won't say it happens in constant time. You won't say it's O of n, right? Okay. You won't say it's O of 1. You won't say it's O of 1. It won't make sense because, of course, you are not going to look through everything here to get it. But the rule number one says you have to take the worst case scenario. So you are going to assume that 1 is going to be at the end here. So you can't say your time complexity in finding 1 in this array is O of 1. You are going to take the worst case scenario. In editing, it's always the worst case scenario, big O notation. So O of here, your big O notation in finding any element in this array is O of n, no matter where the array is placed, because you are taking the worst case scenario. Because you are not, I mean, this is where we have a predefined input. But when you are working in code, you are not going to be, I mean, for how many years I've been programming, right? I have never had to give my own predefined inputs. You are not going to influence user input anyway. So you are going to get it from just anywhere you are, and you are not going to be assured that it will be at the first position. So you have to take the worst case scenario in whatever algorithm you are doing so that you ensure your app runs faster. Then the next thing there is you remove constants. So what does that mean? So say, for instance, we have a function, right, that, let's ignore that question at the top. We are going to solve that in this class. So we have a function that allow us to, I'm not thinking of something off the book now, something that we have to loop any function, and inside this function, we have to loop through the array twice. So we can say for int I is equals to 0, I is less than array dot size, depending on the language, I plus plus. You have this, then you do this, and you do it twice in this function. Now, given that the big O notation of this first one is O of n, because you are going to look through all the arrays. You are going to look through all the elements in the array. And also you are doing that twice. So the big O notation here should be O of 2n. That's, this one is O of n. O of n. And here too we have O of n. So in total, this function is going to take O of n, that's O of n plus n, which will give you O of 2n. Right. But 2 is a constant. 2 is a constant. So the second rule says remove constants. So you are not going to say your big O notation is O of 2n. That doesn't actually make sense. Your big O notation will actually now become O of n. So yeah, you are using the worst case scenario, but 2 is negligible here because you are talking about n. When you try sizing n, I mean n could go up to, you could have arrays that takes up to 1,000 records. So what is 2? When you are talking about 1,000, if you are multiplying 1,000 by 2, it's not going to change the fact that it's not going to change it much, because 2 is just like a constant, because sorry about that. You know that 2 is little or negligible compared to n, so you have to drop any constants while doing big O notation. Say for instance, we also have let's say in this function, this is not an ID function. We have another operation. If A is less than B, do one thing here. The big O notation of this, because you are going to evaluate O notation for every of your statements, functions, and loop. The big O notation of this, since is constant time, you have something of O of 1, right? If you have maybe, let's say it's Y is equals to A plus B, the big O notation of these two is going to be O of 1. So in this case, if you are adding up everything, here you have O of n plus n, but you are still going to add O of 1 and O of 1. So you'd be like O of n plus n, or O of 1 plus 1 plus n plus n, which is going to give you O of 2n plus 2. Since we are still removing constants, you are going to get O of n. So mostly once you are getting all these things, they are not really going to affect the time complexity that much. Of course, it's going to affect it a bit, but it's not going to be as compared to when you are doing loops. This is where, like I said earlier, while we are going through it, that this is where major problems come from, right? While I was writing data structure and algorithm, I was good in finding solution to problem, but I was looping, how do I call it, unprofessionally, and then I lost a lot of interviews then because of they were checking performance. And so once I took data structure and algorithm course, I knew O of n and know how to do this. So your major problem is going to come from these two things, not really from this. Majorly, this is where most apps become slow. I don't know if there's any web developer here that has tried to implement data tables with maybe records going to 1 million or so. I mean, if there's anybody that has done that, you can indicate by raising up your head. I mean, if you have implemented data table for records that are very, very large. I was working in a Nigerian firm then, and yeah, I was an Android developer, so I was not involved in the web team. So you know data tables, you know how to use data tables, you just plug and play, you don't even need to think about the complexity of that. So we had this record, the team we are working on taxpayers record for certain states. So we have to have this record for each local government areas, and the record was about 3 million plus. So we found out that when we put it inside data tables, right, it took about, I mean, there was one time I had to wait for an hour for the page to load, the way we programmed the app, you know, because we are not doing any kind of sorting in data table. And you know about data table does pagination, you can sort each row of the data. I mean, if you've used data table in any of your libraries, you can sort each row of the data. So this the way they built the algorithm is going to go through each record one by one, and then it's going to find out which one we come first, how to index it. So going through 1 million record, and it's not going to go through it once because it's a loop. So that's a loop that I've not really studied the engine behind data tables, but I know that, okay, this is where their problem is coming from, because they are struggling on how to sort 1 million records. Not just sorting it, putting them inside index, because you are going to index by name, you are going to index by age, you are going to index by local government, so that you can easily sort this thing. So once the page is loaded, you can easily sort this thing without wasting that much time. But data tables took like an hour for it to load. So we had to, it was not small refractor we had to do that time because of that. You know, we had to do some certain kind of pagination, but that's just a little bit of how data structure will affect our day-to-day life. Then, for instance, I've had somebody ask me this question that I've been coding every day. No, this for another session. I've been coding every day. I've not seen it used for data structures and algorithms. Then I tell the person, maybe it's because you have been coding in Nigeria. And there's no offense in that at all. I mean, I have been in Nigeria. I never knew data structure and algorithm. The time I tried to go international, I started facing that challenge of data structure and algorithm, and they were particular about it, you know. And I mean, since I started working with Turing, I've been able to implement that in my code, in many code bases. But think about Google search engine, for instance, right? You are in Google search engine, you go to Google page. Let's even try it, google.com, right? Google. Let's say Google, right? So we come here, we are searching for, I've not even done any search, but it's bringing me trending searches. I don't know if you can see this. I just cleared the screen, but they are trending searches already. How is Google able to give us this thing in almost record time? They understand how to use data structures and algorithms. They have great engineers working there. So when you see this company pushing for this thing, it's not because they want to punish anybody. It's because, I mean, if you don't have this knowledge, how are you going to give them this kind of records in this kind of time being? So it's going to be challenging for anybody that doesn't have a knowledge of data structure and algorithm. I mean, if you want to do things in Nigeria, it's fine, but it's going to be challenging. So That's it. So yeah, I just said all those to explain the big role of these things and understand that for loops are the biggest culprits in data structures and algorithms. So this is rule number 2. Rule number 2, remove constants. So then this rule number 3 say different inputs should have different variables. A and B arrays nested should be this. Let me accept this. So what does that mean? So this one, we are dealing with only one function and with only one array. Let's say maybe this is an array. We are passing an array into this function. So we are only dealing with O of n. What if we have a function? I'll copy this. I'll copy this. Say we have a function, go to a new page, that carries array 1 and array 2. Array 2. So what happens if we want to loop through array 1, array 2? Then we also want to apply this loop now for the second array, because you can have functions where you are looping through arrays to different arrays. So here you are having for I is equals to 0, a2 dot size. So if you are saying this is O of n, we are going to say this is, we can't say this is O of n, so we are going to have this is O of b. Somebody will ask, why b, why not n? Because n, like I said, n represents the size of the array. So we are looping through this array. We are looping it through it n times, yeah, because the size is n. But this is, we are not, like we are speculating here, right? But you are not going to expect array 1 and array 2 to have the same size. So in that case, the time complexity of this would be, of course, this one is O of 1, which is 1 here. This O of 1, that's the second one here. This is O of n for this array, first n. This is O of another n, second n. Then we have this, which is looping through the second array. So this is going to be O of b. Now you can say, oh, we can change this from O of n to O of a, O of whatever notation we use to describe it. But n is like, you know, when we are doing math, you say let x be 2. You know, some people is like, why is x 2? Who made x 2? We are just using a random digit here. You can say O of t, O of, but you know, O of n is more acceptable. But when you are dealing with multiple array, most times people use O of a and b to determine that you're using 2. But let's say we still use n yet, so that we should avoid confusion. So this is going to be O of, like I said, this is O of 1. This is also O of 1. This is O of n. This is also O of n. Then this is O of b. So we are going to have O of 1 plus 1 plus n plus b. So you have O of 2n plus 2 plus b. So the final this thing we have is O of b. Now, so why do we have O of b? Because the last, the third rule says different inputs should have different variables. That's O of a and plus b, which is a and b arrays. That's O of a and b. Then a and b arrays nested would be O of a times b. What does that mean? I will get to this when we are solving an assignment here. Somebody could bring it to my knowledge, but there are times where you have to loop through 2 arrays at the same time, and we are going to solve that in this class. But you are going to have O of a times b, and also you can also have O of n times n. Now O of n times n, following this sheet, this is the fastest, then this is the second fastest, this is the third fastest, what you call fourth fastest, n raised to power 2 now is quadratic. So this is, I mean, you shouldn't be having loops getting to this point. I mean, if you are getting to this point, that there's something wrong with your code already, and you really need to optimize. So what is O of n raised to power 2? O of n raised to power 2, we work in the sense that, let's say we want to, we find the use case for that, but let me paste this thing I have here. So we have this, right? We have this array. Then we also have another 4 inside this array, int I is equals to 0, I is less than ARR dot size I plus plus. Now, can anybody, just think through this? What will be the time complexity of this loop? What will be the time complexity of this loop? I mean, if you have an answer, you can say, let me put it on the screen. I mean, if you have an answer, you can unmute yourself and speak. So I don't keep going to the Google. Can anybody tell the time complexity of this? We know the time complexity of only this is n. Okay, I mean, yes, somebody is speaking. I can hear you, but now I don't know who is speaking. Is there somebody answering the question? You can zoom out the screen. Oh, okay, I assume this was spoken like some 20 minutes ago. All right. I mean, in the absence of O of n. All right, that's a great answer, yeah. O of n. But actually, in this case, it's not O of n. Why? We are going through each element of the array here. If we didn't have this here, right, it would have been O of n. But we are going through it. For every time we go through one element of the array, we go through all elements of the array. I don't know if you get. So we are going through each element, but every time you are going through each of these elements, you are going through each of the elements again. I've seen loops like this, and we'll get 2 examples here. So yeah, it's actually not O of n, but it's O of n times n, because for every one n you are doing n iterations. So if the array size here is 2, so for every element you are doing n iterations, it will be 2 times n. But since the size is n and this one is n, you're actually doing O of n times n. And when I say once you start getting to O, that's n times n is actually n raised to power 2, right? So I say once you start getting to these points, man, your code is performing poorly. Because assuming you have 1,000 records, assuming you have 1,000 records or an array of it, that's the size is 1,000. So 1,000 times 1,000, can you guess what that is? This is it. So the difference between 1,000 and 1 million is large. Your app can even crash in this point here. So this is O of n times n. And so once you are getting to this point, Oga, run away. Try optimizing. I mean, someone's microphone is dead, so there's noise coming in. Please, can you? Someone's microphone is unmuted, sorry. All right, thank you so much. So there's also O of 2 raised to power n, which is even crazier than O of n raised to power 2. I mean, in maths, n raised to power 2 is n times n. You can get n raised to power 3 too. I've seen some code like that. I've even tried it in one of the interview. God, the people did not even answer my mail. I mean, I was trying it with TopTal. So I did that in the interview question. I was shocked. Was like, how can you loop through an array 3 times? Like I said, when you get to looping through an array, you are looping through it twice. Sorry, this is already a problem. Then when you do n raised to power 3, okay, so O of 2n now, 2 raised to power n. This is not 2n, this is 2 raised to power n. Well, I don't really have examples for that now. We can do that when we start talking about graphs and 2D programming, but know that you can get into these points. Then O of n factorial. You are adding a loop for every element. Say you have this element right now, right? Okay, we have assumed that this is O of n times n. So let's take this. I want to show you O of n factorial. So for I is equal to 0, I is equal to array dot size I plus plus, we can have, so instead of saying for int I is equals to 0, okay, I mean this code will not run. Of course, we know why it's not running. I'm just using it to illustrate. Because we have I here, we have I here. It should be something like int j, and int j. So yeah, int j, different variable, of course. So in this case, So if you have in j is equals to 0, instead of j is equals to 0, let's say if j is equals to I plus 1. Now, this right here will change the dynamics of this equation drastically. One, because you are not going to loop for every element. You are not going to loop for every element. How do I put this? This one, for every element in the array, you are looping through every other element in the array, including itself. So is that element times the size of the array. So yeah, you are going to be doing it decrementally. So for the first element, you are going to loop through it. Let's say this array is of size 10, so that you understand this. This array is of size 10. For the first element, that's the element at 0 index, you are going to loop through other elements 9 times. So you have to have 10 times 9 because of I plus 1. And the other element, you are going to loop through it 8 times. So you would have something like times 8. Then after that, 7 times, then 6 times, then 5 times, then 4 times, then 3 times, then 2 times, then 1 times. So you know, if we did further maths, or we could do maths in our school, this will be equal to 10 factorial, right? So that's where we have O of n factorial, right? So you are looping, but your looping is not is actually decreasing based on the number of elements. So the first one, you are looping through it 10 times, then the next loop will be 9 times, then the next loop is 8 times, 7 times, until you get to this. So 10 factorial. Of course, there is a tendency that you reduce this, but those are for more complex problems when we get to graphs and everything. We are not there yet. We can't jump into those problem sets yet. So with that being said, I think I've covered, okay, drop non-dominant terms, right? So I'll talk on this later. Just give me, I'll talk on this later in the course, but we'll undo rule 4 because we are not going to enter it right now. But from these basic rules, we can be able to start thinking about our arrays differently on how we solve them, right? So we use this to say what causes time complexity in the function, operations, comparison, and I say all these two things run in O of constant loops. Comparison run in constant loops. Equation double equals to that's constant times this thing. But when you are looping through, you are talking about O of n, because it must take the size of the array. Outside function call can take O of n, can take O of 1, depending on the number of functions you are calling. So that's it. Then let's see. Okay, let's just talk about what causes space complexity in our code. So you can have variables, you can have data structures, you can have function calls, you can have allocations. There's the most popular, answer side for every programmer is Stack Overflow. I don't know if any of you have ever faced Stack Overflow in your code, but if you are writing programming codes like Java, you can have something like Stack Overflow. Why? What is Stack Overflow? Basically, stacks are the memory your whatever operating system is allocating for you to use to attend to any code you are writing, right? In Android Studio, there's a minimum heap, maximum heap that Android Studio will allow you to operate in. So you can use 8 gig of RAM, you can use 16 gig of RAM. And I've been working in projects where I've used 16 gig of RAM, and it's crazy, right? 8 gig of RAM, and it's taking the whole memory. So working with JVM languages, you are going to get a lot of Stack Overflow problems. So what's a stack? A stack is the memory allocated in solving a problem. So imagine, let's go to this place. I wish, yellow, sorry about that. I wish I have a bigger eraser, and I would be able to erase this. Is there a new frame? Oh, sorry about that. That's easier. So say we have this as a container, then we have this, and our app allows us to run 1, 2, 3, 4, 5 functions. That's the amount the stack can take. So you guys are familiar with recursive function. Maybe you want to find factorial. I think keep this in mind. Let's go to there's a factorial function that goes like this. When you have n, then we have let me see, n times, sorry, this should be small letter, n times, calling the function name factorial, n times factorial n minus 1. Sorry about this. So this is like a factorial function, and people know. Of course, there are constraints that you have to put, that if n is equals to 0, return 1, right? Something of this nature, so that it doesn't multiply by 0, which return all the reports to 0. So return 1, else n times n factorial. Now there's a major challenge with this, which you might not find with other languages, is, say we have, holding in mind that this thing has 1, 2, 3, 4, 5 spaces in a stack, and we have to run factorial function. So the first, say we have to run for a number, let's say 7. So the first one we take when n is equals to 7. This one is n when s is equals to 6, when n equals to 5, when n equals to 4, when n equals to 3, and then there's no space for when n equals to 2. So you have to have stack overflow, meaning that I don't have any space to store this anymore, and we can go ahead. Of course, you are not going to get it for low numbers like 7. So in space complexity, if you are calling this function, the number of times you're calling this function is the number of space complexity is going to have. So each function, the number of times it's calling. So this function is O of 1 per se, but the function is being called n times. So the function will return O of n. So no matter, every function that is called takes 1, 1, 1, 1, 1, but depending on the operation inside the function, the memory it will store. Majorly, the way we do it, we return this. So once you do this, you actually override this problem. So you are going to get 7. But instead of continuing, you are returning whatever you are getting. So it's going to take only the first place in the stack. But we are still going to get to that much later. So we don't go much into that. Variables take space. So if you are declaring a variable, if you say int a equals to 0, this is the space complexity of this is O of 1, right? Then arrays take their own space. Say let's have an array of this. Let's call the array 5. The space complexity of this is O of 5. We have gone to a new page. O of 5, because it's taking, now array is taking a space in memory, but array is storing 5 different spaces for this. So O of n, which is O of 5, because we are using a constant O of n. So whatever the size of array is O of n, but in cases like this, it's take O of 1. So in these cases, this can look negligible, but when you are studying array, hash map, those things begin to take O of n spaces. Functions begin to take O of n spaces. If you have a function, let's call this function multiply 2 nums, and we have int a, int b. Now this function is space, then we say return a times b. Now the space complexity of this time complexity now is O of 1, O of 1, time complexity. So time here is O of 1. But space complexity now can't be O of 1 again, because first the function is taking 2 variables. It's going to create space for 2 variables. So space complexity will be O of 2, which in that sense will be space complexity O of 2, which in that sense will be this. But if you are taking an array, say we have instead of O of n and this, we have int b. So this will now turn to O of n. And depending on the time complexity of what we are doing here, it will affect the time complexity. But the space now is O of n, because remember, functions in Java I think in Java you don't pass functions by reference, you actually pass them by value. So if you've done pointers, memory management in any of maybe C++, it's not a very popular language right now. Nobody likes coding in C++, but to teach you about how to manage memory code, ooh, we have spent a lot of time. All right, so with this, it's about a 1 hour course. But I mean, is there anybody that has any questions so far? Let me attend to questions now, and let's know how we are attacking the next problem. Any questions so far? Do you understand? Is there any area that you need clarity? So if you have any questions so far, you can raise your hand. You can even unmute yourself and speak. Okay, Philip. Philip, please, your question.
Okay, sir. The last part.
Yes.
I want to understand the last part.
Okay, what part?
Time complexity.
Time complexity.
Time complexity. Yeah.
Okay. You joined. Okay, I just. Oh, my network is pretty bad. I had to leave. Please drop the link to the recording. Okay, I see some people complaining about network, and it's raining here, so I think I should shout louder. Can you hear me clearly now?
Yeah.
Okay, so what exactly about time complexity don't you understand? Time complexity, like I said, is the time it takes for your code to run. If you have simple operations like if A is equals to B, if A is greater than B, if A is less than B, A times B, A plus B, A minus B, A divided by B, which other, let's see. All these things are running in constant time because, I mean, to compare two values, the compiler just need to see them and say, oh yeah, A is equal to B or A is not equal to B. So that's it. But once you start having challenges like looking through an array, for instance, you can have a find function, find, let's say find lowest number. Let's use find lowest. And you take an array. Now I'm declaring the function here. It's not like we talk more about functions, but now find lowest. This array, since because we are going to, basically this is how it's going to be, its lowest is equals to ARY, the 0th element, right? Then I think somebody joined the meeting. Yeah. This is how basically we solve this. Then for int I is equals to 0, I is less than ARY dot length dot size I plus plus. If lowest is less than ARY I lowest equals to ARY I. And take a look at this function. This operation here we run in O of linear time, I mean constant time, because we are taking the first elements. Accessing any elements in an array is O of 1. But then we are going to loop through this array, and we are going to loop through it. We don't know the specific time to take to loop through the array. It depends on the size of the array. So in this case, the time complexity of this now is going to take the time it will take to run depends on the time, the size of the array. So in that case, we now have the time complexity of running this function as O of n, because we are looping through each element once. And why we use n to indicate here, because n is not going to be a constant value. No matter what you are coding, you don't know the size of the array they are going to give to you. You are going to deal with array that I mean, if you start dealing in this light, you are going to deal with array that are very, very large. It's a given. It's I know that for certain. It's a given. You have to deal with that. So if you are going to look through the array, you should be aiming for O of n at the best case in your district. If not, I mean, your algorithm will perform low. So in this case right now, we are talking about time complexity, right? To access any element in the array runs in O of 1 time. The same thing with any kind of all these operations. They run in constant time, O of 1. But once you start looping through an array, because you don't know the size of the array, you are going to be sure that the looping will be as fast as the array size. So if the array is smaller, it will loop through it faster than if the array is larger. But companies that are majorly looking into data structures and algorithms, they are going to deal with what you call big data, large. You are going to deal with large records. I gave an instance of when we are working on a tax app and we had up to 1 billion taxpayers on the system. And we had an instance where the page took an hour to load. And I'm not talking about a foreign-based company. I'm talking about in Nigeria. It's not like it's Google or Microsoft or anything. So knowing your space and time complexity, you can manipulate data in such a way that it will not take forever to load. Right. Of course, it's not our error for us to get that. We are using a library and we did know the inbuilt time it takes to do that. But knowing time complexity will help. I don't know if I answered your question. And so
Yeah. Thank you very much.
Yeah. I mean, if you you might not grasp everything right now. Philip, I will get back to you, please. Philip is there, right? You might not grasp everything right now. One of the challenges I faced when I was learning to, I was like, okay, this big O of space and time we are talking about, what is it? But like every programming concept, once you start practicing it, you start saying, oh, this is how it is. Oh, this is where it makes sense, you know. So you are going to get more understanding with time. I mean, everybody here has tried programming one time or the other in their life, and you know that theoretically, after you finish a course content like this, you feel like King of Kings and Lord of Lords. Until you try to solve a problem, you're like, so how do I start applying this thing? So that's I would understand that since maybe it's new when you're getting into all this concept, but you will grasp it, trust me. So Philip, sorry, can I hear from you?
Oh no, I think thank you very much. I think my question has been answered somehow.
Okay.
Yeah, so I was trying to understand the whole concept, like the whole big. What is that O? That when you say big O, what does O stands for?
Oh, okay. Big O notation is a programming term they use. There are 3 types of notations. There's big. Okay, I wrote this down. It's not like we use that every day, but where are we? Omega notation. This gives the best case complexity. You see, these things they just use letters from God knows where they use it. So big O is determining the worst case scenario, time complexity this year. There's also omega notation, which gives the best case complexity. These are some engineers, some mathematicians try to find out data structures and algorithms. In other ways, they are trying to find out how to make a machine faster. So they try to bring out this concept to say, I don't know, there might be some arbitrary terms that we use in programming that, in a sense, don't make sense. Of course, graphical user interface makes sense, but let's see. Spring, if anybody has done Spring, what does Spring stand for? Kotlin. What's the meaning of the word Kotlin? It might get its meaning from, God knows where it gets its meaning from, but it's standing for something now. So your mindset should not be like, okay, why did they use O? What's the name O? When they say big O notation, they are trying to say, okay, what's the worst case this program can run? There's also theta O notation, which gives the average case complexity. But in every data structure and algorithm course, right, they are not going to measure your best case. They are not going to measure your average case. Remember the rules we have here. We have this rule, always worst case. We are looking for the worst case. That's why we are looking out for it, because you are not going to determine the kind of input user is going to send to you. If you are designing for mobile, you can't you don't have full control over what the web is going to send to you to record. I mean, we just did this thing on Google search and we have all this record. Google does not care what we are searching for. They just give us the trending search. And how do they find the trending search? I don't think everybody that came to search this thing, I don't even know who these guys are. Of course, I know a lot of people search iPhone, Apple iPhone 14 Pro Max, but maybe I didn't word it as Apple iPhone 14 Pro Max. Maybe I word it as iPhone 14 launch this thing. And of course, I said that news because it was a big news in the tech space, right? So we also have this, we have the Midnight Giants, a lot of news. I don't even know why Trent Alexander-Arnold is trending, but it's not me, it's Google that is telling me that. Oyo landlord skeleton. Interesting. I would love to read this news, but not now, right? So you don't really need to look at Bigo like, what does it stand for? What does Java stand for? We are learning the language Java. What does it stand for? PHP, what does it stand for? I mean, PHP is one of even the controversial language in what it stands for, because the name PHP, they say it's hypertext preprocessor, and we are saying it's PHP. How is it hypertext preprocessor? But I don't know if that will make it clear, because you might think, okay, Bigo, you want to understand why the name Bigo. No. It just stands for worst case scenario. We are trying to find space and time complexity. That's all.
Yeah,
Does that answer your question?
yes, that's very
Okay.
clear. Thank you so much.
Okay. Yeah, so once you are hearing it, I mean, the first time I heard it, they were just throwing it around a lot. I was like, in fact, the first interview I went to, and they say, what's the Bigo notation of this code? I was probably professional. I was like, Bigo notation. I didn't even know what it was. I was like, please, can you throw more light, And it was funny, it was embarrassing, but we learn with it. So that's it. And we have spent 4 minutes into the time. And I really don't want to go much ahead right now. Okay, Raphael, you have a question, so please can you ask?
Sorry about that. I think I mistakenly pressed the hand button. Yeah.
Okay, no problem. Thank you.
Thanks.
Love it. Yeah, no problem. Love it.
Okay, I just want a clarification for the space complexity. When you talk about function, is it that because like I use Python more, so sometimes we have arguments which are like you just put args and you have a keyword args. So I want to know if when it comes to function, is it like the number of single parameters, let me use parameters, single parameters that is required for the function that is the space complexity?
Yes, I will say that. See, like this book, right? What causes space complexity? We have variables, very, very key element. Every variable takes O of 1. If it's a linear variable, like if you have int A, int B. But if you have an array is not going to be O of 1, because an array is not, arrays generally takes more space than integers, right? They just take more space. So they take more space. So we are not going to have a, okay, let's put it this way, with our compiler, sorry. Oops. So we have this, right? So we explain how the function calls all these things. Say we have this now. So first function, maybe a function called, let's see what function. Let's say we want to take man to moon. Yeah, we have this project that we want to take man to moon. So first things we have to say, get rocket charged. Get man to moon, have to call the function get rocket charged. So once rocket is charged, we now have to find out get man in rocket. After that, we have to have now man is rocket on rockets, right? So before you do any of this, you have to wait for each function. So say this is the general function, and this function calls each of these functions before this function is done. So we can have this like this take man to moon function will be here, right? So there's another space now for our stack. So we get rocket charge. Get rocket charge will stay here. But once get rocket charge is done, it releases all the space it ever took. And so the next function can come into that space. I don't know if you get. But then let's say we have this function, turn on rockets. Maybe there's this encapsulated part of turning on rockets that I think somebody tried to join the meeting. Let me admit that person. Turn on rockets. So we have insert key, turn key, whatever else function you have to do to all this. I'm just giving a high-level definition, but in a real life scenario, this is what you are going to do. So first of all, take mark to moon is here. It takes that space. It's full. That space is occupied. Then it calls this function get rocket charge. Since the space is occupied, it goes to the next space, get rocket charge. So it waits until get rocket charge is done. Then get rocket charge is done. Then get money to rocket is another function. That function will take this space after get rocket charge has released the space. Then when that get money rocket is done, you know, it returns true of course. Then turn on rockets. Now turn on rockets will now stay here. But turn on rockets now has other functions like insert key. Insert key will now stay here. Turn key will now stay here. So once rocket is turned on, maybe you want to return that. Once that function is complete, it will release all this memory it took. So you see how function holds memory sizes, right? These are function takes up memory. So if you call, that's why when we are doing the recursive function here, I did something like this. This return. Return is going to ensure that this function is not going to take space. If we are returning this, instead of these two things taking this extra space, this space will be replaced by whatever is going to be here, because return is going to close this function with the result of this function. Since it's closing this function with the return of this function, it's not going to take another space for this function. It's going to replace whatever this function is with the next function. So return, but we are going to see more of that in code. But every function we take as much space as the variables the function also declare. So I'm just using this in this case. For instance, the function will now store more variables. Using stack to explain it can be a little bit tricky because I didn't do compiler design. I mean, if there's anybody that did compiler design here, I took the classes at school and I ran away. I ran away for my life. It was quite difficult. We are talking about mainly abstract things, but this is exactly what they teach there, how the memories are managed in computer space. I've worked on some Arduino and Raspberry Pi projects. The maximum amount of RAM you are given is 4 megabytes of RAM. So you can't even afford to try to code anyhow you think you can, because the space will get filled easily with just variables, right? So managing that will help you know that should I create a variable at this point? Is the variable necessary? Should I create this function? Should I wait for this function to be done before I call another function? Also, there's also the place of concurrency, parallel programming, multiple programming, and all that. But every function takes space. Rocket. So we have this, right? So say the turn on rocket as a variable. So I'm putting like, it's not like the compiler has predefined segments for each memory is releasing. So this function initially takes 2 megabytes at start, but as it's calling other functions, the memory increases. So it might not be this line that is demarcating it. It might just be that this function now takes this whole full space because it's waiting for this function to complete. So the more variables a function is declared in, I mean, the more space it takes until it fills this finite space that the app gave to it to run. And once it fills this finite space, you can have things like Stack Overflow, majorly exception. But I think developers these days, we have hardly gotten into Stack Overflow. But as an Android developer, I've experienced Stack Overflow one too many times. It has just come up in areas I'm like, oh, I need to optimize my code for that. I don't know if that answered the question. Sorry. Hello, Vex.
Yes, for the most part, yes, it did.
Okay. Okay, sorry. I Gideon was raising his hand and then he has left the meeting. Okay, I think we should take a break right now. I didn't know that. I mean, it's good that we took the first lesson, understanding the basics and the concept, so we can go further into more solving the equation later. But I don't want to use any much of our time. But there's this problem. I will copy this and put on the group, right? And the next class we are going to solve it. I want to hold a class tomorrow because while we submitted the form, the majority, a good number of people asked that we hold it on Saturday and Sunday. So we have like almost 60-40 saying Saturday and Sunday. So for now we'll be doing Saturday and Sundays, and since the recording will be set, we would have to. I'm not going to repeat what we dealt with on Saturdays and Sundays, but we'll go into solving real life problems and seeing how data structure and algorithm will help in that, especially how to think through a problem and solve. So thank you so much. Any other feedback, let's say, or question? I mean, if you have a question, you can drop it on the group, right? So we don't spend much. Yeah, okay. Raphael. All right.
Yeah, finally, I have a question. Yeah, so I wanted to ask, like, what resource can you recommend for someone that wants to learn this, like, outside of this place?
Okay.
Like,
Okay.
yeah.
Also, master recording interview. I have this. Now I can't. I took this course before I joined Spring, right? So, here's the home page of the course, master recording interview. Speaking of a couple of courses, I will share the link online. So this master decode interview, big tech, FANG interviews. This course helped me a lot. I've recommended it to some persons. There are two courses that goes on this, and we teach you all the data structures and everything, but I would recommend this course. I would copy the link and send. Now, I don't know the cost of this course right now. It's not going to show on my dashboard. Yeah, I do have scholarship for every Udemy course, so I don't pay a dime for any course I want to study on Udemy. So yeah, it's part of the package. So I will send it to you. You can pay for it and learn it as much as you can. I think it will help. But what I was doing here is so that we could have an interactive session, because I think I have sent some couple of people this course, and I don't know if it didn't help them, they didn't have the time to go through it, or I think for me too, I still find that laziness. Sometimes I need a tutor that will show me some ropes in the game. But yeah, I would highly recommend this course and another one I took. So that's we do. Okay, yeah. The course is just posted on the group, so you can have it right now. Thank you so much, Raphael.
Of course, you said you are going to share this document.
Yes, this big old data sheet. I will share it as soon as the call is done. The recording of the meeting. Let me stop presenting for now. The recording of the meeting now. Since I'm using an enterprise server, it takes some time for it to be ready. But even if it's ready, I might need to. Yeah, I might need to, do some. What's it called now? Maybe some editing or stuff, so that I could proofread and ensure that the right content is going out. So thank you so much, everyone, for coming. Thank you, Anto Mengi. Thank you, Abso Webs. Thank you, Bapi Kabiru. Thank you, Emmanuel Ugoji. Thank you, Idris Benga. I think I know Idris Benga. We've run a project together too. Hi, Idris. Thank you, Emmanuel.
Hey, Peter, well done. I saw your distance. I was like, okay, let me join and
yes,
and learn one or two things from you. That's awesome. Well done.
Thank you so much. And you guys should see.
Yeah, there's this other course I can recommend for people too. Go Monster. It's just that it's expensive. right?
Oh,
But it's just like grokking the coding interview. It's quite an awesome one too, for those who can
oh,
afford to buy it.
oh, okay. I mean, you can send it on the group. If you see the link, it will be
All right,
awesome.
no problem.
Thank you. Then Emmanuel, my major help since the days of John the Baptist. The guy has been of great help to me. I mean, if you have questions, you can trouble Emmanuel too, because I okay. Emmanuel say you guys shouldn't trouble you. Okay, just drop the questions on the group, right? Sometimes it's quite busy trying to put attend to some questions, right? I just had my leave this past 2 weeks, so I really had to put time to undo some other things. So, but Emmanuel has been a great help for me since my assistant programmer. Kenny Banky, hi, so good to have you here. Love it. Duke, hello, thank you so much. Moshud Mustafa, hello, hi. Oluwafumito Blessed. Is that a female name or a guy's name? I can't really tell. Hi, Blessed. Hi, Mushu. Peace, you turn. Okay,
Guy.
Blessed is. Yeah? You're a guy?
Yes.
Okay, great. I mean, one of the challenges we had when we enter into the international space, this thing about the transgender community, it was a team, it was a strong team. So you don't want to mispronounce somebody's name or give them a pronoun they don't like you call it he, a she, or a she. I mean, it's quite amazing. Here over in this part of the world, we don't usually face that. So I became more careful in addressing people. So hi. Peace you town. Hello, Philip Obekpa. Hi, Philip. Hold on. I think, Philip, you're the one that recommended me to get the laptop I needed, right? I think it's the one.
Yes.
All right. Thank you so much for the recommendation. That was so awesome. Thank you. And Raphael, thank you so much. Thank you so much. Thank you so much, guys. I couldn't thank the other people that left. There was network issue, and sometimes within it, I had to shout. But we are taking more than 19 minutes of the time. I think we'll work on a much better time. But I believe we learned something, and we could continue with the momentum we are building. I wish once I joined Turing at first, I recommended a lot of people for the role, and they were falling short in data structures and algorithms. And it was painful for me because it was as though I passed it, and the guy was like, recommend somebody now. And a few people I recommended, they weren't able to pass it, and it was painful. And at a point, I stopped attending to his course because I was like, So I think I really want more Nigerians to get into that space, because a lot of people helped me on my way forward. So Idris is here, Philip is here. Out of webs, I a long time ago. So appreciative of all those helps, and it's a way of giving back. Thank you so much. With that being said, we would end the meeting for today. Have a fantastic evening rest and enjoy an happy new week ahead. Thank you so much.
Thank you very much. Good night, everyone.
Thank you, boss.
Thank you. Bye.
Thank you.
Thank you.